Good day, seniors. In this video lesson, we'll be having permutations. So by permutations, we all now know that it means arrangements. So arranging all numbers of a set into some sequence or order. So very important here, the word order is very important. So the number of ways of arranging n things is simply given by n factorial. So you know that n factorial is simply n times n minus 1 times n minus 2 and so on up to 1. Okay, now let's have a problem to solve. Let's have this first. Find the total number of 5-digit palindromes. So what is a palindrome? A palindrome is simply a number or a string of numbers or a string of letters which can be read in which is read the same way in either direction. Let's say an example: 1, 2, 4, 4, 2, 1. This is a palindrome. So when you read it in this direction, it's 1, 2, 4, 4, 2, 1. Also here, it can also be letters like no lemon, no melon. So if you see, we read this no lemon, no melon in this direction, and you read it in this direction, you get no lemon, no melon. So it's a palindrome. So basically, you get the idea. So let's solve this problem. Find the total number of 5-digit palindromes. So you are having a 5-digit number. So of course we can select from the number 0 to 9. So we can select from the number 0 to 9. We cannot take 0 as our first number because it won't be a 5-digit number. So we have 9 choices for the first digit. And the next digit, so if this is 9, this place is taken by any of these 9 numbers. For it to be a palindrome, it should also be the last, so it's 1. So no other way for this but to be the same as this. And for the next digit, we can now choose all of them. Because 0 can now be a number that's after this digit. So if this is taken by 10, this would be 1. Remember, whatever this number here should be also the same here. The number is here should also be the same here. That's why it's 1. Now for the middle number, we have 10. So all in all, we have 9 times 10 times 10. We have 900 such palindromes. Let's have another. How many 5-digit palindromes are less than 3,500? So we have less than 3,500. That number should be beginning with 3, 2, or 1. So if it begins in 3, then the second digit must not be, so if it begins with 3, the second digit must not be 6, 7, 8, 9, and so on, because it would be a number that is greater than 35,000. So let's divide our cases into 2. So case 1, if this digit here is either 1 or 2. So if it's 1 or 2, so we have 2 choices here. So that means whatever we pick here, it's also the same here. It's a palindrome. Okay. Now for the next digit, remember we can now select all, even 9. So if this is 2 or 1, and then this would be any number, it will satisfy less than 35,000. So what we have here should also be here. And for the middle digit, it can be any number. So all in all, we have 200 palindromes that starts with 1 or 2. What about case 2? So in this case, that's when the number starts with 3. So if it starts with 3, obviously, it's already taken by 3, 1. So here's also 1. Now, how many digits can we put here to satisfy this condition that it's less than 35,000? So we cannot put 6, we cannot put 7, we cannot put 8, we cannot put 9. We cannot actually put 5, because if this is 5 and this is 35,000, it's not less than 35,000. So we have only 5 digits to choose from here. So 0, 1, 2, 3, and 4. So 5 digits here. And then the next would be, of course, this whatever we put here, it's also here. And this would be 10. So all in all, we have 50. So we have 2,250 palindromes less than 35,000. That's it. Now just to check, if you want to check, you can get the number of 5-digit palindromes that are greater than 35,000. Let's do that. So here, we know our answer is 250 from these two cases. Now let's try to answer that. How many 5-digit palindromes are greater, this time greater than 35,000? So case 1 would be if this is 4. If these are the numbers from 4 to 9, you can choose from the digits 4 to 9. Obviously, it will be greater than 35,000. So that will be 4, 5, 6, 7, 8, 9. There are 6 of them that we can choose from. 1 here, it's a palindrome. 10, 1 here, and then 10, we have here 600. Now for the number, if the palindrome begins with 3, if it begins with 3, this spot here is taken by 3. Obviously, it's only 1. So for the spot of 3, 1 here. And then for the next digit, we can actually pick 5, 6, 7, 8, 9. These 5 numbers. Because if we pick 5, 6, 7, 8, 9, this would be like 35,000 something, then 36,000 something, a palindrome like that. It would be greater than 35,000. So this spot will be taken by 5 digits here. So obviously 1 and then 10. So we have here another 50 palindromes. So all in all, we have 650 palindromes which are greater than 35,000. Now just to check, we know the total number of 5-digit palindromes. These are less than 35,000. This is greater than 35,000. Notice if you add, it would add up to the total, which is 900 palindromes. Let's have classic examples of permutation problems. Let's have here, this one. In how many ways can 6 boys and 4 girls be arranged in a row? So there are no conditions, just you have a total of 10 students that will be seated in a row. So it's simply 10 factorial. Next. In how many ways can 6 boys and 4 girls be arranged in a row such that the girls form a single block? Now notice here that let's have the 10 seats. So let's go 4, 5, 6, 7, 8, 9, and 10. Suppose these are the 10 seats. Remember, there are 4 girls and they must be together. They should form a single block. For example, these 4 seats will be taken by the girls. They want to be together. The boys can sit anywhere they want. So you have here 6 arrangement for the boys. So basically this is 6 factorial. But remember that this will form a single unit. Therefore, all in all, there are 7 arrangements. So 6 for the boys and 1 for the single block of girls. But if you look if you look at the group of the girls, in their little own universe, they have their arrangements as well. Suppose girl A, girl 1 wants to sit here, girl 2, girl 3, girl 4, or girl 4 here too. So there are 4 of them which they can arrange themselves in these 4 seats as long as they are together. So that will be 4 factorial. So let's leave our answer here just like this. 7 factorial and 4 factorial. Let's have the next. Okay. What about this problem? In how many ways can the 6 boys and the 4 girls be arranged in a row if a certain boy in the group named Jean and a certain girl from the group named Abby insist on sitting together? Remember, there are 10 seats. 4, 5, 6, 7, 8, 9. And if these two star-crossed lovers want to be together, they will share the same seat. These 2 seats might as well be glued together. We have a total of 9 seats to arrange all in all, because remember, this will be taken as 1. So we have a 9 factorial here. And remember, in their own universe here, they have their arrangement to themselves. let's say Jean here, and then Abby here, then Abby and Jean, as long as they're together. Such a happy story. So 2 factorial. So that's it for that problem. But this last one, okay. In how many ways can 5 boys and 4 girls be arranged in a row if the boys and the girls must sit alternately? So if they sit alternately, so again, let's write the spaces to represent the positions: 2, 4, 6, 7, 8, 9, 10. So for them to sit alternately, we must start with the boy here. So boy, and then girl, boy, girl, boy, girl, boy, girl. So 1, 2, 3, 4, and then boy. And then there are only 5 boys and 4 girls, so we have this space here should not be here. So we have 5 boys, 1, 2, 3, 4, 5, and 4 girls, 1, 2, 3, 4. So how many ways can a boy sit here? So there are 5. And then of course, how many girls can sit here? 4. And then remember, a boy is already seated here, so there are only 4 to choose from here. Girl should be 3, and then boy 4. 2 already seated in these 2 spaces, so 3. So notice that it's simply like this: 2, and then 1, and then 1, or simply 5 factorial times 4 factorial. That's it. Because we cannot make a girl sit in the first seat, because if it is a girl, then boy, then girl, then boy, and then girl, then boy, girl. Remember, there are 4 girls, so these are the 4 girls already, and 5 boys, so it will be like this if we started with a girl. So it cannot have 2 boys sitting together, right? The girls and the boys must sit alternately. So this cannot be, no? But love wins. So anyway, this in the next video lesson, we will be answering permutations of this kind. In this lesson, we are answering only arrangement of n things, which is n factorial. Next time, we will be answering what if we arrange or select r things from n things, which will be given by this formula, of which you already know a little bit. So until that time, so the best way to learn, don't forget, is to do it yourself. Good day.